To fight severe deforestation and restore a deeply degraded landscape, Kenya has committed to planting 15 billion trees by the year 2032. It is a massive afforestation mandate. Meeting a quota of that size requires finding the most efficient nature-based solutions available, and that search quickly leads to bamboo, the fastest-growing woody plant on Earth. Below ground, its dense rhizome network acts like a massive subterranean sponge. It actively increases water infiltration, heavily mitigates topsoil erosion, and stabilizes riverbanks to prevent devastating floods. But there is a hidden catch to deploying it at scale. Because the demand for planting stock is so high, commercial growers almost entirely rely on vegetative cloning. They take an existing, high-performing plant and divide it into thousands of cuttings and rhizome offsets. This approach is cheap, and it gets plants in the ground quickly. Yet it inadvertently weaves a massive biological vulnerability into the very landscape we are trying to restore. Woody bamboos are predominantly monocarpic. This means they experience gregarious flowering. After decades of steady vegetative growth, an entire population will simultaneously bloom, produce seeds, and then die immediately after. The trigger for this mass death isn't environmental, it's an internal genetic alarm clock. And because vegetatively cloned bamboos are exact genetic copies, every single clone shares the identical biological clock as its mother plant, regardless of where it is planted or what the climate is like. This diagram illustrates clonal propagation risk. If a project plants 10,000 hectares using clones from a plant 40 years into a 60-year cycle, the entire forest dies in exactly 20 years. Immediately, root systems decay, soil stabilization fails, erosion follows, and sequestered carbon is released. By relying exclusively on vegetative clones to meet their planting quotas, large-scale restoration initiatives are unknowingly planting a biological time bomb that can destroy their own progress. The only scientifically sound way to bypass this vulnerability is to grow the forest directly from seeds. Look at the right side of this chart. Germinating a seed entirely resets the biological clock. It guarantees a fresh, uninterrupted life cycle of 50 to 150 years, complete with the genetic diversity needed to resist disease and extreme weather. The challenge is actually acquiring them. Bamboo seeds are exceptionally rare. They only appear during those massive, synchronized blooming cycles, which are governed by specific prime numbers, like 48 or 120 years. When they do drop, the seeds are incredibly fragile. They lack long-term dormancy mechanisms and possess a narrow natural viability window of just 3 to 6 months. Without precise cold storage facilities and careful desiccation, they die quickly. Securing these seeds and keeping them alive is an intense race against time. It requires exact horticultural science, far beyond the scope of traditional farming. This is exactly the logistical challenge taken on by the Earthkeepers Foundation. Their mission is to secure East Africa's ecological future by mastering the mass production of seed-grown bamboo. This flowchart outlines their deployment model. The foundation has expanded the Kanali Mega Nursery to produce 8 million biologically secure seedlings annually. Surviving this phase requires strict protocols like surface disinfection and controlled shading, which feeds into the flowchart's base, building a sustainable bioeconomy. Once those seedlings are stabilized and planted in the field, they undergo an explosive vertical growth phase. Driven by intense hydrostatic pressure and rapid cellular elongation rather than cell division, a new shoot can grow over a meter in a single day. By mastering this exacting nursery science, the foundation turns a rare botanical anomaly into a highly scalable defense against climate change. A successfully established seed-grown bamboo plantation matures in about 7 years. After that, it provides a century-long return on investment. This chart tracks carbon sequestration rates. Elite bamboo species at the top pull 26.96 metric tons of CO2 per hectare annually. Comparing this green bar to the gray bars below, bamboo vastly outpaces the carbon removal of traditional tropical rainforests. This intense biological pump is highly valuable on the voluntary carbon market. High durability removal credits derived from these forests can yield a farmer roughly $440 per hectare annually, solving early cash flow problems. Seed-grown bamboo transforms landscape restoration from a charitable expense into a lucrative, non-extractive financial asset. Providing genetically resilient seeds is useless if the receiving farmers do not know how to manage this aggressive, rapidly expanding resource. Proper silviculture training is required. Farmers learn the crucial rule of clump maintenance. They must only harvest the mature 3-year-old culms during the dry season, while leaving current year shoots entirely untouched to fuel the underground root system. This harvested timber fuels localized industries like biochar production and eco-textiles. These microenterprises directly combat poverty and create diversified, green rural employment, reducing the migration of youth to urban centers. This is supported by smart policy. Kenya recently reclassified bamboo legally as a grass rather than a tree. This removes complex bureaucratic hurdles for timber felling permits, allowing farmers to harvest and commercialize their crop freely. By rejecting the short-term convenience of cloning and executing the difficult science of seed propagation, East Africa is engineering a resilient, self-regenerating bioeconomy capable of outlasting us all.